Good morning, afternoon, or evening, cats and dogs. This video will focus on the lesson 8.8 guided notes on solving multi-step inequalities. We are going to begin with questions 1 through 11. The bell may ring during this time, so just ignore it. For these questions, we want to solve each of the following inequalities, then graph the solution on a number line. We are going to solve these two-step inequalities or equations with variables or inequalities with variables on both sides, or those that contain grouping symbols, the same way we solved equations. So in number 1, we have 6x plus 15 is greater than 9. We want to begin by getting rid of our constant of 15. The inverse of adding by 15 is to subtract 15. This will get us 6x is greater than negative 6. 9 minus 15 is negative 6. Then, for our second and final step, we want to divide both sides by 6. That's the inverse of multiplying by 6. That will get us a solution of x is greater than negative 1. This will have an open circle because it's greater than and not equal to. If it were equal to, then we would have a closed circle. Notice how we line up our numbers, smallest on the left, largest on the right. So negative 2, negative 1, 0 from left to right. Since its x is greater than, we are going to shade to the right. Our number lines are no different than when we had our one-step inequalities, so we're going to go through those pretty quickly. All right, let's take a look at question number 2. We have negative 16 is less than 6r minus 4. We want to get rid of our constant of minus 4 here, so we're going to add 4 to both sides. Negative 16 plus 4 is negative 12. So we have negative 12 is less than 6r. Just like our last question, the inverse of multiplying by 6 is to divide by 6. So I get negative 2 is less than r. Notice how I don't need to flip my inequality symbol around here or in number 1 because I divided by a positive 6. I do suggest, though, for number 2, rewriting it with the variable on the left. So I do suggest rewriting it as r is greater than negative 2. Both of these solutions have the exact same meaning, so both would be correct. It is easier to graph, though, if the variable is on the left-hand side. So I put my numbers in order from least to greatest from left to right, negative 3, negative 2, negative 1. We have an open circle at negative 2 since it's greater than negative 2 but not equal to negative 2. Greater than, just like our last question, means we're going to shade to the right. Don't forget, if you need to pause the video at any time because we're moving through these too quickly, don't be afraid to do so. All right, question number 3. We've got to mix in some decimals here. The inverse of adding by 6.8 is to subtract 6.8, so we'll do that first. 10.5 minus 6.8 is 3.7, so we get 3.7 is greater than b over 7. The inverse of dividing by 7 is to multiply by 7. No need to flip the symbol around since we're multiplying by a positive. So we get 25.9 is greater than b. Don't forget to practice plugging these into your calculator as well to make sure that you're calculating them correctly. I do suggest rewriting it with a variable on the left. That's not the same as flipping the symbol. We're just rewriting the same inequality as an equivalent inequality by rewriting it with a variable on the left. Now I chose to count by tenths, so 25.8, 25.9, 26, although you could do 24.9, 25.9, 26.9, or something similar. This one, like our last two, is also going to have an open circle. Its b is less than, so we're going to be shading to the left. Again, all of these are either a less than or greater than, which is why we have an open circle. All right, let's take a look at our next 3. Number 4 is also a two-step inequality. So we're going to start by adding 10 to both sides. That's the inverse of subtracting by 10. That will get us k over negative 5 is less than or equal to 2. Negative 8 plus 10 is 2. Then we will multiply both sides by negative 5. That's the inverse of dividing by negative 5. But because we multiplied both sides of our inequality by a negative number, as I'm going to highlight in yellow here, that means we need to flip our inequality symbol around. So for our final solution, instead of k is less than or equal to, we will get k is greater than or equal to negative 10. Put our numbers in order from least to greatest, negative 11, negative 10, negative 9. This one is a closed circle because it's greater than or equal to. And since it's greater than or equal to, we are going to shade to the right. Just like this. All right, number 5, I do suggest adding the opposite for this one because you've got your variable coming after subtraction, which did not happen on any of our previous inequalities. So we're going to rewrite this as 8 plus negative 1t is less than negative 10. Now let's use our inverse operations. The inverse of adding by 8 is to subtract 8. That will get us negative 1t is less than negative 10 minus 8, which is negative 18. The inverse of multiplying by negative 1 is to divide by negative 1. Like our last question, though, we're dividing by a negative, or multiplying by a negative, as it was in number 4. So we're going to flip our inequality symbol around. So the t is going to stay on the left, but our symbol goes from less than to greater than. And of course, negative 18 divided by negative 1 is positive 18. This one, like our first 3, is an open circle. Watch your order of your numbers from least to greatest left to right, so 17, 18, 19. Since our final solution is t is greater than 18, we are going to shade to the right, just like this. All right, so now we're going to get into some more complicated inequalities. These we might have to simplify first and then solve. So in number 6, because the variable comes after subtraction and I'm going to simplify, I'm going to add the opposite and rewrite minus 3y as plus a negative 3y. Now let's combine our like terms. The negative 3y plus the 1y will get us a negative 2y. So now it's a two-step inequality. Your goal is always to get it down to a two-step inequality and then a one-step inequality. Let's get rid of that plus 1. The inverse of that is to subtract 1. That will get us negative 2y is greater than or equal to 4. Now divide both sides by negative 2. And since we're dividing both sides by a negative number, we are going to flip our inequality symbol around. So we'll get y is less than or equal to negative 2. We really want to be careful with all these steps. Keep in mind, with the increasing number of steps we have, the easier it is to make mistakes. It's not a big deal, but we want to keep all of these important things in mind, like adding the opposite, switching the symbol when we multiply or divide by a negative, and so forth. Since it's less than or equal to, we are going to have a closed circle at negative 2, and less than or equal to means we are going to shade to the left. So our final solution will look like this. All right, let's move on to number 7, 8, and 9. So number 7, we have distributive property involved in this question. So let's distribute our 4 into the parentheses. So I'll do 4 times x and 4 times 3. So we'll get 4x minus 12 is greater than 6. We're going to start solving this by adding 12 to both sides. That will get us 4x is greater than 18. The inverse of multiplying by 4 is to divide by 4. This will get us a decimal here, so we'll get x is greater than 4.5. No need to switch anything around since we divided by a positive value. Now, I put on my number line 4, 4.5, and 5. You could do 3.5, 4.5, 5.5, whatever is easiest for you. This is an open circle at 4.5, and since it's greater than, we are going to shade to the right. Number 8, another distributive property question. Let's distribute this negative 4 into the parentheses. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. Let's get rid of this plus negative 8. The inverse of that is to add a positive 8 to both sides or subtract negative 8. That will get us 11 is less than negative 4x. Divide both sides by negative 4, and since we're dividing both sides by a negative value, we are going to flip that inequality symbol around. So 11 divided by negative 4 is negative 2.75. The less than symbol became a greater than symbol, like this. We flipped only the symbol around, and then we should rewrite it with the variable on the left, which does not change the meaning. So from this green highlighted statement to the statement below, those are equivalent solutions. We just rewrote it with the variable on the left. So I chose to count by 0.25 or by quarters, so I put negative 2.75 in the center, negative 3 to the left, negative 2.5 to the right. But that's not the only way you can count, as long as you count evenly. We've got another open circle here, and again, our final solution, ignore that bell, is x is less than negative 2.75, so we're going to shade to the left. Let's go ahead and do that. And we are going to get our graph or number line that looks like this. All right, we have a handful more questions to see. Now we're going to have grouping symbols and variables on both sides. None of these are going to be a no solution or all real numbers kind of situation. Doesn't mean you may not see that in the future with inequalities like we did with equations, but we're not going to kick it up that far of a notch, at least not at this point. So let's take a look at number 9. What I would suggest you do first is add the opposite, but also distribute. So I definitely want to get rid of these parentheses as one of my first few steps. So we have 5a plus negative 8 is greater than or equal to 4a minus 12, which I wrote as 4a plus negative 12. 4 times a is 4a, 4 times 3 is 12, but again, a minus 12 becomes plus a negative 12. Now we want to get the variables on the same side. 4a is smaller than 5a, so I suggest moving that. The less negatives we can have, the better for sure here. So let's subtract 4a since it's a positive. That will get us 1a, or just a on the left, plus negative 8 is greater than or equal to negative 12. It's important you keep the numbers on the same side of the inequality that they were already on. Now it's just a one-step inequality. We're going to add 8 to both sides. That's the inverse of adding a negative 8. That will get us a is greater than or equal to negative 4. Notice how I did not need to flip the inequality symbol around here. Now, if you choose to do it differently, like subtract 5a to both sides here, you may need to flip the inequality symbol around. So we really want to be careful how we do this. This is another reason to move the smaller variable expression to try to avoid some of those negatives at the end. So I put my number line, negative 5, negative 4, negative 3 from left to right. This one is a closed circle because it's greater than or equal to. Again, that line underneath indicates that it's going to be a closed circle. Since it's greater than or equal to, we are going to shade to the right, just like this. All right, we have 2 more for this video. Let's take a look at number 10. First thing I want to do is distribute this negative 2 into the parentheses. So take negative 2 times k and negative 2 times 1 will get us negative 2k plus negative 2 is less than negative 16 plus 5k. Negative 2k is smaller and it's negative, so I suggest adding 2k to both sides. Again, not the only way to do this, but if you subtract 5k on both sides, you're probably going to need to flip the inequality symbol as one of your final steps. So we'll be left with negative 2 on the left, negative 16 plus 7k on the right. Now the inverse of adding a negative 16 is to add a positive 16. So we will get 14 is less than 7k. Now divide both sides by 7 and we will get a solution of 2 is less than k. Although I do suggest rewriting it with the variable on the left, so k is greater than 2. All right, we did not flip the symbol around here. All we did was rewrite it with the variable on the left. I'm going to have an open circle at 2, and since its k is greater than 2, I am going to shade to the right. All right, last one. And these get pretty difficult towards the end. They might be a little easier on your test than we have in your guided notes, but I'm also trying to prepare you for algebra, not just for your unit test. So we have to distribute twice here, the 2 into the first set of parentheses, the 5 into the second. So the first set will get us 2p plus 18. Don't forget our plus 6. It's easy to drop that off. On the right-hand side, we'll have 5p minus 15, which I did rewrite as 5p plus negative 15. I would suggest combining the 18 and 6, which are like terms together, to get 2p plus 24 is greater than or equal to 5p plus negative 15. 2p is smaller than 5p, so that's what I would move. It's positive, so I would subtract 2p from both sides. That will get us 24 is greater than or equal to 3p plus negative 15. Now it's a 2-step inequality. Let's add 15 to both sides. To get 39 is greater than or equal to 3p. Divide both sides by 3 to get a solution of 13 is greater than or equal to p. I would rewrite it with the variable on the left, which would be p is less than or equal to 13. Again, if you write 13 is greater than or equal to p, that's correct as well. Now, this is going to have a closed circle this time because it's less than or equal to. And since it's less than or equal to, we are going to shade to the left, just like this. All right, let's go ahead and finish these Lesson 8.8 guided notes, and we're going to start with questions 12 and 13. We will also see questions 14, 15, and 16, but beyond that, we do have some extra challenge questions, and we will not go through those in this video. So let's begin with number 12. This is going to be our multi-step inequality set of guided notes with word problems. So number 12 says you earn $2.75 for every newspaper that you deliver, plus a salary of $15 each week. Write and solve an inequality that can be used to determine how many newspapers you must deliver if you plan on earning $180 each week, and interpret your solution. So when we go to look at this question, the first thing that we want to look at is what our variable is going to represent, which will be our unknown. So let's go ahead and highlight some important information here. It says we want to determine how many newspapers you must deliver in order to earn $180 each week. So I'm going to let my variable be n, and that's going to represent the number of newspapers that you want to deliver if you plan on earning $180 each week. We don't have to write all of that out though. Now, some other important information that we have. We know that you earn $2.75 for every newspaper, and keep in mind that n represents the number of newspapers. So I'm going to put an n right here above the word newspaper. So it's $2.75 for every newspaper that you deliver. And then we say plus a salary of $15 each week. So that's going to be in addition to the $2.75 for each newspaper. Other important information that we have is that you plan on earning $180 each week. And that helps us since we're talking about $15 in salary every week and $2.75 for every newspaper delivered. It's beneficial to highlight that important information, mark up the text, and reread the question as necessary. So let's put all of this together. The inequality that I'm going to write is $2.75 n representing the number of newspapers, plus 15, and then I use the inequality symbol greater than or equal to. Now, unfortunately, in this question, it doesn't say at least or a maximum or a minimum of, but it does say that you plan on earning $180 each week. So we wouldn't want to earn less than $180. We'd want to earn at least $180 each week. So if you plan on earning that, we want to think at least. And at least is our greater than or equal to symbol. It's $2.75 n since it's $2.75 for each newspaper, and then we're going to add on that salary of $15, and again we want that to be greater than or equal to $180. The writing the inequality part is the new part, solving it is not, so let's go through those steps. We're going to subtract 15 from both sides as our first step. That will get us $2.75. n is greater than or equal to 165. Divide both sides by $2.75, and that will get us that n is greater than or equal to 60. And what that means for us is our interpreting the part where we're going to talk about what that means. N is greater than or equal to 60. N represents the number of newspapers that were delivered. So to interpret our solution, we're essentially going to write our solution in sentence form. So what I put is that you must deliver at least greater than or equal to. We want to use some phrase that says this is greater than or equal to. So you must deliver at least or perhaps a minimum of 60 newspapers if you want to earn $180 each week. Make sure you state something, and I'm going to highlight that word at least. Make sure you state something that indicates the greater than or equal to symbol, at least or a minimum of, some kind of wording that tells us that we want to deliver greater than or equal to 60 newspapers. All right, let's take a look at question number 13. So in number 13, it says, Barb brought her car to the mechanic. The mechanic said that the job was going to cost at least $425 for parts and labor. If the cost of the parts was $125 and the mechanic charges $50 per hour, write and solve an inequality to determine how many hours the mechanic is planning to work on the car. Interpret your solution. First off, let's determine what we're trying to find. It says that we need to determine how many hours the mechanic is planning to work on the car. So let's let H represent the number of hours. Let's read the question again. The mechanic said that the job was going to cost at least $425 for parts and labor. That word at least is going to indicate what inequality symbol we are going to use. At least is our greater than or equal to symbol. We even saw that in number 12, even though that phrase was not used. So we're going to have greater than or equal to $425. We know that the cost of the parts was $125, and that's just a flat fee or flat rate. And we also know that the mechanic charges $50 per hour. And don't forget, H represents the number of hours. Oh, not the number 5, of the variable H. Let's go ahead and put all this together into an inequality. I wrote 50H plus 125 is greater than or equal to 425. The 50 and the H go together since it's $50 per hour. We want to add on that flat rate of 125, and again, at least is our greater than or equal to symbol. Let's solve this inequality. We're going to subtract $125 from both sides. That's going to get us 50H is greater than or equal to 300. We'll divide both sides by 50. 300 divided by 50 will get us 60 as well. Go ahead and delete that box. Maybe I can't delete it. Or not 60, sorry, 6. Goodness, I can speak today. Sorry, I was trying to delete the box at the same time. 300 divided by 50 is not 60. That would be a lot of hours they're working on the car. That is 6. So we get H is greater than or equal to 6. And let's interpret our solution. Remember, H represents the number of hours. So H is greater than or equal to 6 means that the mechanic will work on the car for at least 6 hours. Remember to use some sort of phrase that indicates your inequality. I used at least again. You could say that the mechanic will work on the car for a minimum of 6 hours. That would work as well. All right, let's move ahead to question number 14, which is a multi-part inequality word problem. Number 14 says as follows. Elise wants to take her friends to the movies, using the $139 she has saved. Each movie ticket costs $9.50, and she plans on spending $25 on food. Write an algebraic inequality that can be used to determine how many movie tickets she can purchase. So it tells us in this part what we're trying to find. It says, to determine how many movie tickets she can purchase. So I'm going to define a variable to represent that, and I think I chose the variable t. We know that she is going to use the $139 she has saved. Now, unfortunately, again, it doesn't give us any phrase that indicates what our inequality will represent. We'll talk about that in a moment. We know that each movie ticket, and don't forget we're going to use a variable to represent that, perhaps t, to represent each movie ticket, costs $9.50. So right now I'm thinking $9.50 t. We also know that she's going to spend $25 on food. So $9.50 for each movie ticket, t, plus 25 is what she's going to spend. And we know that she has $139 saved. So let's think what inequality makes sense. Well, if she has $139, can she spend greater than $139? She can't. So we want her to spend less than or equal to the $139. So the inequality that I wrote is as follows. I let t represent the number of movie tickets, and I wrote $9.50 t plus 25 for the food. We want that to be less than or equal to $139. Again, because she has $139 and she has to spend in total with the ticket and the food less than or equal to $139. All right, let's solve this inequality. We'll subtract $25 from both sides because part B asks us to solve it. That'll get us $9.50 t is less than or equal to 114. We'll divide both sides by $9.50, and that will get us t is less than or equal to 12. Let's explain what that means. That's our interpret our solution. T represents the number of movie tickets. So we know that Elise can buy a maximum of. Again, I'm going to use a word that's going to tell us what our inequality means. A maximum of, we could say less than or equal to, but a maximum of 12 movie tickets in all. So part D says, can Elise afford to buy 12 movie tickets? Well, she can buy a maximum of, which includes 12. So we can say for this one that yes, since the inequality is less than or equal to, she can buy up to and including 12 tickets, and that's for her and her friends. Now, if we said, can Elise afford to buy 13 movie tickets? She could not, because it's less than or equal to. And most real-life situations are going to be that less than or equal to kind of situation. If we said, can Elise afford to buy 11 movie tickets? She would also be able to purchase 11 movie tickets because she can purchase a maximum of. So she could buy 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12 movie tickets, but anything more than that she would not be able to afford. All right, let's move ahead to number 15. Samuel went to the park with $18. Admission costs $4 and each ride costs $1.50. If Samuel bought a drink for $1 and bought nothing else while at the park, what is the maximum number of rides that Samuel can ride? All right, well, we're talking about the number of rides that Samuel can ride. And we use this word maximum as well. I'm going to highlight that. That's going to be a pretty dark blue there. But maximum is going to indicate less than or equal to in some amount. We know that Samuel went to the park with $18. So kind of like our last question, we know he wants to spend less than or equal to $18. We also know that admission costs $4. And each ride, and we're talking about the number of rides here, costs $1.50. So I defined a variable to start. Oh, maybe I didn't define a variable. We'll talk about it in a moment. What I set up here was admission plus drink is 4 plus $1. So our admission was $4. We know that he also purchased a drink for $1. I'm going to see how I set this up first. And that's going to be a total of $5 that we know he spent, on top of the cost for the rides as well, which we'll define in just a moment. So we know he spent $5 on top of the rides. The inequality that I wrote, and I didn't define the variable here, so let me go ahead and define R as the number of rides. So it's $5 between our drink and admission. We got that from up here in this portion. 5 plus $1.50 for each ride, so $1.50 R. And again, because he has $118, goodness, I swear I can talk today. It's been a long week already. Because he has $18, 118 would be fantastic, right? Since he has $18, we want him to spend less than or equal to $18. All right, let's go ahead and solve this inequality. Subtract 5 from both sides. We're going to get $1.50 R is less than or equal to 13. We'll divide both sides by $1.50, and that's going to get us R is less than or equal to 8.6 repeating. Now we notice 8.6 repeating is one of our options. Your calculator, by the way, might say 8.666666 and end with a 7. It's just rounding that last digit up. This is really 8.6 repeating. But Samuel can't ride 8.6 repeating rides. That's 2/3 of a ride. So we can eliminate that choice because it doesn't make sense. We also can eliminate 9 because if it's less than or equal to 8.6 repeating rides, he can't ride 9 rides. So it asks for the maximum number of rides that he can ride. He can ride 7 rides or 8 rides, but if we're looking for the maximum, that's going to be 8 rides. This is one of those word problems that I think is really tough because you want to write and set up an inequality to represent this, define a variable, solve it, and then figure out which of those solutions works. Another option that you could do is you could actually kind of calculate this yourself. So you could say, well, he spent $4 on admission, $1 on the drink, that's 5, plus $1.50 times 9 times 8 times 7 and see which of them will get him less than or equal to $18. If he rides 9 rides, I'm going to calculate that here. I'm going to do 5 plus $1.50 times 9. That's going to get him at $18.50. If he only has $18, he cannot ride 9 rides. So our next highest that he can ride is 8 rides. All right, let's finish up these guided notes. Number 16. Philip is selling tickets for the school musical. He has already sold 20 tickets and can sell up to 12 tickets per day. If D represents the number of days and Philip wants to sell at least 86 tickets, which inequality represents this situation? Well, we see that phrase at least 86 tickets. At least is greater than or equal to 86 tickets. So I'm looking for any inequality that says greater than or equal to 86. D has that. C does not. That's less than or equal to 86. Choice A is less than or equal to 86, but choice B is greater than or equal to 86. So I know it's choice B or D. Now what we also know is that he's already sold 20 tickets and can sell up to 12 tickets per day. Don't forget that D represents the number of days. So we're going to have 12 times D plus the 20. We're looking for the inequality that has the variable D with the 12, since it's 12 tickets per day. That happens to be choice B. So choice B is the only inequality that makes sense here. It should be 20 plus 12D is greater than or equal to 86. And we don't have to solve this. All right, again, I'm going to skip over 17 and 18 in these guided notes. You've got enough to help you be successful on this writing and solving multi-step inequalities. Thanks for listening.